Hi, this is Glenn Dane, Professor of Material Science and Engineering at Ohio State University and Director of the Hammer Engineering Research Center. I'm here coming from you from Chicago, Illinois, the International Machine Tool Show to introduce the Agility Forge. Let me give you a brief introduction to it, and I'll let the primary developer, Brian Thurston, tell you a little more about it. It's basically a Tormac mill that we've taken, and rather than machining, we're primarily making parts by deformation, the way a blacksmith might. This is something that's done in a way that's material agnostic. We can put in copper alloys, steel alloys, nickel alloys, you name it. We use an induction heater to do the heating. Our friends at Ambrell developed that. By tuning things, we can heat a wide variety of materials. We've got a press, an electromechanical press provided by Promes with a novel tool changing apparatus that allows us to put different shaping elements on there, do bending, piercing, you name it with that. We can make all kinds of shapes with this. We can get to near net shape. We can do very big things with this, much bigger than a human blacksmith could. We can make net shapes that are close to the desired shape, really reducing machining waste. We can get forged properties out of this. We can start with a casting. We can start with something that's made by additive manufacturing, some kind of hybrid amalgam, weld something together, do final finishing to get real forged properties. We can do a lot more with this. Within this same system, we can do scanning, we can do machining, we can do heat treatment. We can put the cover over this using an inert atmosphere to avoid oxidation. This is basically ready to go, ready for beta testing. We're eager to really put this to work. I'll show you what's on the floor at IMTS through the voice of Brian Thurston, showing it live at IMTS. Stop by and see us at booth. Sharon.
So this is the Agility Forge. So this is a fairly novel concept in the family of metamorphic manufacturing, or we also call it robotic blacksmithing. So this machine is built on a Tormac CNC mill. So it's a 3-axis CNC mill. We've added a 4th axis to this device. We've also added a 6 degree of freedom compliance device, we call it. And the compliance device has a chuck on the front. The chuck holds the workpiece. Now, the compliance device protects the mill from unwanted lateral forces, unwanted torques, and other potentially damaging forces that arise from this. This unit here is a forging press. So in the back, we have a servo-driven press. In the front, we have a series of tool changers, and we also have proximal to all that an induction heater, so we can heat up a piece of steel or aluminum, and then in the forging press we can apply deformations to move a part from a stock geometry towards a target geometry specified by the user. Eventually, we're hoping that this machine will be able to replace, to some degree, replace closed die forging with a process that is much more flexible, which does not require expensive tooling and which does not have a long lead time. To help with that, we have right here, we have a 2D line scanner. You can see the blue laser line from the 2D line scanner, which can capture 3D information about the geometry of the part when we rotate the part on the 4th axis of the CNC mill.
So that's it. Please come see us. This is really a collaboration with a lot of my friends and colleagues at our National Science Foundation Engineering Research Center. Also important is support from the Steel Founders Society of America, and TMS has done a great job in helping us get the word out with one report and another one that's issuing October 7th. A lot of information is on our Hammer website, hammer.osu.edu. Please come see us, reach out to us. We'd be happy to partner with you. Thanks so much. Hope to see you. Bye.